When I was growing up, there were 9 planets in the solar system. Then poor Pluto got the boot, and we went down to 8. Now, scientists claim they have found a new 9th planet orbiting far beyond Pluto. Tonight, the Sky Night investigates the case for Planet 9.
On January 20th, 2 astronomers from this university, Caltech in Pasadena, Southern California, made an extraordinary announcement. They claimed they had compelling evidence that a new, as yet unseen planet was orbiting the Sun, far beyond the existing planets.
So far, this is a theoretical discovery. The planet's existence has been predicted by computer models, but if it does exist, it throws up many questions. Where is it? What does it look like? And most crucially, how did it get there?
We'll be talking to astronomers here in California and in the UK to answer those questions and to find out what a discovery of Planet 9 would mean for our understanding of the solar system.
But first, let's put Planet 9 into context and see how it fits into our understanding of the rest of the solar system. This is what we thought was the extent of the solar system for thousands of years. And it's restricted to the planets we can see with the naked eye. So in the centre, of course, we've got the Sun, then Mercury, Venus, Earth, Mars, Jupiter, and 1.5 billion kilometres from the Sun sits Saturn. And this is all we thought that there was until the 18th century. Since then, the solar system has gradually expanded. In 1781, Uranus was discovered, followed in 1846 by Neptune. Tiny Pluto was added in 1930, bringing the edge of the solar system out to 5.9 billion kilometres away from the Sun. Pluto was counted as a planet for over 70 years. billions of icy bodies and comets, called the Kuiper Belt. It was thought that the Kuiper Belt marked the outer edge of the realm of the planets. But now it seems that that might not be the case. For some of us, it's an extraordinary thought, but many astronomers have long suspected there may be other planets lurking in the dark expanse beyond the Kuiper Belt. And we're getting the first evidence that suggests they may be right. To get a feel of just how far away Planet 9 is, if it exists, we need to plot its position in relation to the rest of the planets. On this scale, every centimetre is about 35 million kilometres. The Earth is 150 million kilometres from the Sun. Pluto is 40 times further away. And the outer edge of the Kuiper Belt is still further. But Planet 9 is far beyond that. At the point of closest approach in its orbit, it sits 200 times further from the Sun than the Earth. That's a whopping 30 billion kilometres away from the Sun. But unlike the other planets, the proposed orbit of Planet 9 is not circular. Its highly eccentric path takes it much, much deeper into space. At its furthest possible point, its aphelion. It could be as much as 1,200 times further from the Sun than the Earth. On this scale, it is 54 meters away. In reality, it would be 180 billion kilometers from the Sun. And because the orbit is inclined by 30 degrees to the rest of the solar system, it means it's also above or below the plane of the rest of the planets. It seems almost unbelievable that there could be a planet so far out in the solar system. A mysterious world, 10 times more massive than the Earth. On an orbit so long, it takes between 10 and 20,000 years to complete one lap of the Sun. But how was the discovery made? Chris drew the short straw and flew to California to find out.
main story is an astronomer here at Caltech. And he's got history when it comes to changing our views of the solar system. 10 years ago, he was instrumental in demoting poor old Pluto, and even wrote a book about it. His name is Mike Brown. Brown's speciality is the Kuiper Belt. In 2003, he discovered Eris, a Kuiper Belt object bigger than Pluto. A discovery that was instrumental in Pluto's demotion. A month later, he co-discovered Sedna. This was the first of what became 6 unusual Kuiper Belt objects that have been found with highly eccentric orbits that take them far out into space. They were 6 of the most distant objects ever found in the solar system. It was studying their orbits that led Brown to the idea that there might be another planet out there. So the story starts with the outer bits of the solar system, the Kuiper Belt. What we found is that the most distant objects that are part of the Kuiper Belt, so these ones that come into the Kuiper Belt but swing out really far, the very most distant ones, if you look at their orbits, all of their orbits are pointing off in one direction instead of being randomly distributed around the sky. So how tight is that alignment? The ones that we know for sure that are aligned are 6 objects, and they're aligned within about 107 degree swath of the sky. Something like this. Yeah. Okay. And it's not just the alignment in direction as well. The orbits have other things. Well, so first you see the alignment in the direction, and then you realize that these 6 very most distant objects are also all tilted in the same direction, downward and a little bit to the side. They're within about 7 degrees of being in the same skewed plane as of each other. And the combination of those two is what really shows you that there's something strange going on. Because, you could get the things, the 6 of them lined up just due to chance. It's about a 1% chance you would get it due to chance. About 1%, it's a small number, but it's not that small of a number. But if you take it also in the fact that they're tilted like that, that's another approximately 1% chance. So it's about 0.01% chance that this is all just randomly aligned. So is that what got your attention and got you working on the problem? That was the big clue that something is going on in the outer solar system. This was an extraordinary finding. The tight clustering of the 6 orbits might have been caused by the gravitational influence of something massive in the outer solar system. For Mike Brown, the question now became, what was out there and how could he find it? Working down the corridor from Mike is theoretical astronomer Konstantin Batygin. Mike and Konstantin have worked together for ages, and it always helps to have a friendly theorist on hand. And so Mike popped in to see if Konstantin could help with this problem. Konstantin's expertise is building computer models of planetary systems. Hey, how are you doing? Yeah, nice to see you. And so Mike challenged him to build a computer model of the solar system that would replicate the strange orbits of the 6 Kuiper Belt objects. When you started looking into this problem of these strange orbits, I know that a planet wasn't the first thing you considered. What else could have caused this effect?
We had a whole slew of explanations that we decided to look into first. Self-gravity of the Kuiper Belt, so the mass of the disk itself holding itself together in a coherent fashion.
All the bodies pulling on each other, essentially.
That's right, to create almost a fluid-like effect. As it turns out, the Kuiper Belt doesn't have enough material for this to be relevant. If it was 1,000 times more massive, that model would have some pull. We looked into whether or not a passing star could sort of perturb the structures and leave this long tail of orbits that we're now here to observe. Such encounters don't happen very often, and moreover, the alignment would go away over time, so this would have had to be recent.
And there's no sign of a very nearby star. It's just done this.
That's right. So I think it's a very uncomfortable route to go.
And so, with all of that out the way, you start to think about planets.
We were careful to ensure that we're not chasing a red herring here, that this data is indeed real, the alignment is not some observational bias, it can't be a coincidence, all of that before going down the path of introducing additional planets into the solar system.
When he started adding planets to his models, Batygin experimented with thousands of possible orbits until he found one that replicated the strange orbits of the 6 unusual Kuiper Belt objects.
Suppose that the orbit of Neptune is about this big.
Okay.
Most conventional Kuiper Belt objects, Pluto included, have orbits that sort of hug the orbit of Neptune and are oriented every which way. But importantly, if you look at the whole Kuiper Belt from afar, it looks like a more or less axisymmetric disk.
Yeah.
This rule of thumb is broken when you look at the most distant orbits.
So these are the now famous six.
That's right. If you look at the now famous six, they all tend to swing out into the same overall direction.
So your simulation predicted a nice elongated distant Planet 9 orbit.
Planet 9, sort of a similar sized orbit, but it's facing the wrong way.
You might as well draw the planet on. Go on. We haven't seen it yet, but just for satisfaction sake.
The planet, I'm pretty sure it's in this part of its orbit.
Because otherwise we would have found it.
We would have found it.
Right, okay.
That's
fine. So there's our planet.
So there's our planet. And it's fascinating. Most of the time, the objects spend on opposite sides of the solar system. They're completely unaware of each other throughout most of their orbits. It's only when they come around at perihelion, when they're closest to the sun, when they get closest to the sun, they temporarily interact, and the mechanism, of course, is just gravitational interaction. And that's what maintains this lockstep.
So every time they come round, they get this kick, or every 2 times, or...
No, it gets complicated. For some orbits, it's every 33 times of this orbit per 19 times of this orbit. But fundamentally, it's not too different from tugging on something repeatedly in a coherent way.
But Dickens' model had passed the first test. It had successfully replicated the orbits of the famous six. But there was another unexpected effect. The model also predicted a second set of Kuiper Belt objects with even stranger orbits. Trouble was, they didn't seem to exist.
The biggest twist to the whole story came when our numerical models consistently would generate orbits that looked more or less like this.
They're sort of coming in and out of the blackboard here.
That's right, they're on their sides. They're perpendicular to the plane of the solar system. Right? This is just so weird, the fact that the simulation is producing these orbits that should be perpendicular, they should be readily observable, and the fact that we don't know of them is big trouble.
So it's not just that they might be there, they have to be there.
We initially thought of this as counter-evidence to the existence of the planet. Fine, it explains alignment, but it also predicts stuff that's clearly not there.
This was the key moment where we looked at it and said, this makes no sense. But then I started looking more carefully at the other objects in the data set that I had not been paying much attention to in the last couple of years. There are 5 of these objects that are on perpendicular orbits that I remember when one of them was discovered a few years ago and thinking, that's just weird. Nobody had any explanation for them. And I said, Constantine, I'm going to go plot these right now, and we're going to see where they are. And if they're sitting right at these 2 spots right here, my head's going to explode. And we plotted them. One of them is right here. 4 of them are exactly right here where we predicted. And we just both sat there and stared at that. And I think my jaw hit the floor. It really was an honest, blind prediction of something we didn't know was there. And that when I look at those objects on those wings, and then I see those aligned objects too, I think I really am pretty convinced it's really out there.
If Planet 9 does exist, it would be a remarkable discovery. The first new planet to be found in our solar system in 170 years. That isn't to say it was completely unexpected, because there are places we have found planets that are similar to Planet 9. I went to University College London to be exoplanet expert Professor Giovanna Tonetti. Giovanna, if Planet 9 does exist, it seems to have some very exotic characteristics compared with the rest of our solar system. In your work in exoplanets, have you seen anything similar to these characteristics out there?
Well, we're talking about an object that is about 10 times the mass of the Earth. This kind of objects are classified as super-Earths, which is a very exotic name, and NASA Kepler satellite tells us basically that these are among the most frequent objects in our galaxy. But we didn't have any objects of this particular size with a bit puzzling in a certain sense. But if planetoid does exist, then of course we're ticking the box and we also have our own Instagram.
So we had one missing, and now we look as if we've got one.
Exactly.
But Planet 9, if it's out there, is a whopping 200 astronomical units away from us at its closest approach. So that just seems an awful long way away. Have we got examples of planets that far away from their sun?
Actually, we do. And what you see now is GU-BCSB, which is located 2,000 astronomical units from the star.
So that's the further reaches of Planet 9 potentially. Yes.
This is a real image, by the way.
The fact you can actually take an image like this is amazing.
It's really very cool.
Okay, so we've looked at the size, we've looked at the distance from its local star, but now it's also a very eccentric orbit, and that seems quite exotic for our solar system.
It definitely is. Most of the planets in our own solar system are orbiting in orbits which are almost circular. But actually, however, we are seeing planets that are orbiting in extremely elliptical orbits, and we have some examples like this planet that is called HD 806 or 6b, and as you can see from this picture, we have planets out there that are orbiting in very elliptical, or we call it eccentric sort of orbit.
So if Planet 9 does exist, it isn't as exotic as we perceive it to be, because there's lots of other examples out there that are similar to the characteristics of Planet 9.
You're right, Maggie. And if Planet 9 were sort of proposed and discovered before exoplanet were found, probably would dismiss this case, saying, well, this is way too eccentric, this is way too odd. We can't have a planet like this. And the fact that, on the contrary, now we know that planets like this can indeed exist, is really making the case for Planet 9 even more interesting.
Well, thank you very much. It's been fascinating speaking to you.
It was a pleasure.
In theory, there's no reason why Planet 9 should not be out there. But there's only one way to prove its existence, and that is to directly observe the planet. Mike Brown took Chris to the famous Griffith Observatory to look at the skies above LA and to point out where he thinks Planet 9 is.
Okay, well, clear sky, sort of. Where is it? Where's this planet?
Well, we know its path across the sky. We know its orbit, so we know the path. And the path across the sky goes from somewhere over here up across
course, all the way back around. We actually also know that around Orion and Taurus is where it's the most distant from the sun. And we think that's where it is. We think that the places that are closer to the sun, it would be too bright. We would have seen it already.
Okay, so in some sense you're already getting some observational data on the planet. You know where it isn't, and you know other things as well.
The other thing that we would know is that if it's too big, if it's the size of Saturn or the size of Jupiter, it would have been detected by the WISE spacecraft a couple of years ago. So they did a survey of the whole sky looking for things that move, and we now know that there's nothing as big as Jupiter or Saturn out to many, many times the distance of where we think Planet 9 is. So it has to be small meaning the size of Neptune or maybe a little bit bigger. And it has to be pretty far away still, and somewhere off in here.
And pretty faint. Otherwise, I mean, we're not looking at telescopes here to find this.
No, in the end, it's going to take us some time on the biggest telescopes in the world. But with the biggest telescopes in the world, it is well within range, and we'll be able to find it.
Be exciting.
Yes.
So I know you're looking for it. Lots of other people will as well. I'm sure they will. Now, does it bother you who's going to find it?
I would love to find it myself. I would love to have that moment, which I've gotten to have before on these big objects in the Kuiper Belt with Eris, where you see it, and for a moment, you are the only person in the history of humanity who has seen this object so far away. I would love that. I will not lie. At the same time, I want it to be found, and so if somebody else finds it first because they were searching hard for it and helping us out on this search, yes, I will feel just my heart will sink a little bit, but I think that'll be overcome by the fact that I was so excited that it was found.
It's up there somewhere, probably.
Right there.
One of the big questions about Planet 9 that we will have to answer if people are to take the claim seriously is how did it get to its current orbit? To get to the bottom of that question, I've come to Queen Mary University of London to meet Professor Richard Nelson. Richard, what's the problem with the proposed orbit of Planet 9?
Well, it's very difficult to form a planet on an orbit like that. And we believe, according to current models, that it would take almost the age of the solar system in itself to form a planet all that far out.
Because it has to accrete onto the body.
That's right. It's the accretion process which brings small agglomerations of material together and builds larger and larger objects, leading eventually to a planet. All the way out there just takes far too long because it's moving around very, very slowly and there's a very low density of material there as well.
So if it didn't form out there at the limits of the solar system, where did it form?
Well, our best guess is that it probably would have formed among the existing giant planets, Jupiter, Saturn, Uranus, and Neptune. So there are, theoretical models already which indicate that if you run computer simulations of the early solar system, the evolution, you have a dynamical instability. Having a fifth planet there actually helps those models reproduce what we see in the solar system today.
So that fifth planet could be planet 9.
Could very well have been planet 9, which is no longer there, but orbiting further out.
So what are we seeing here?
What we're seeing here is a computer model of the early stages of the solar system, but with 5 planets. So you've got the white planet there, that's planet 9, and the other planets, Jupiter, Saturn, Uranus, and Neptune. You'll see that the planets are going around essentially on circular orbit.
As you'd expect.
As you would expect, that's right. They're all interacting, they're all perturbing one another. But planet 9 in this simulation is a little bit too close to Saturn when it starts. And at some point, we're going to see it have an encounter which gives it quite a dramatic little kick, and you'll see it change. There you go. So that's right. So you see that. And this keeps going on and on and on. Jump forward and you can see that the planet's orbit has expanded a lot, and they have a very eccentric and a very inclined orbit.
So does that do it? Does that give us the orbit of planet 9?
Well, unfortunately not, because planet 9 has an orbit where the closest approach to the Sun is about 200 or 300 astronomical units away. So, as you will have seen here, planet 9 keeps coming back into the inner solar system and continues to interact with the giant planets there. Eventually, one of those encounters will be strong enough to throw it out of the solar system altogether.
But how can you stop it from pinging off out into the galaxy?
Well, I think if planet 9 is actually proven to be there, it's going to tell us something very interesting and very important about the origin of our solar system. So what we've looked at so far is a solar system forming in isolation. But now let's imagine that the solar system formed within a star cluster. If we look out within the galaxy, we see that stars do tend to form within groups and within clusters of stars. If planet 9 was thrown out into one of these very, very eccentric orbits while the star cluster was still there, then gravitational perturbations from the star cluster could have caused planet 9 to change its orbit when it was at its most distant position from the Sun. So I have a simulation which shows that here. When it goes out on this orbit this time around, it's not going to come back in anymore. There's going to be an interaction with a nearby star which changes the shape of the orbit, just like that.
So suddenly it expands outwards and stops going back into the inner solar system.
So that's what saves it from being ejected from the solar system.
So a lot of your model does seem to tie in with the evidence we're seeing for Planet 9. It could explain the sort of the huge orbit, the inclined orbit, and why it's still there and not out there in the galaxy.
That's right. That's why I said at the beginning that I think proving that Planet 9 is present within our solar system with the orbit suggested would also indicate very strongly that our solar system didn't form in a lonely place but was part of an earlier starburster.
Pretty fantastic stuff.
Wonderful.
Thank you. It's been fascinating.
Pleasure.
And that leaves one final question. What sort of planet is Planet 9? And what are the conditions like so far out in space? At the far reaches of its orbit, the Sun would appear tiny, just a point of light. But it would still be the brightest star in the sky. Although the Sun would be 1,000,000 times dimmer than it is here on Earth, it would be 1,200 times brighter than Venus appears to us. That far from the Sun is very cold. Some estimates have suggested it could be below minus 250 Celsius. As for the qualities of the planet, we don't really know. The computer models suggest it should be 10 times more massive than Earth. But it could take different forms. One possibility is that Planet 9 could have been ejected from the inner solar system early in its development, when it was just the core of a giant planet. This would make it predominantly rocky and icy. Now, with 10 times the mass of Earth, it would be twice the diameter, and it would probably appear to be a dark, pinkish red in colour. But if the planet was ejected when it was more fully formed, then it would have a chance to build up the gassy layers like Neptune and Uranus. Then it would be much less dense and so bigger, maybe 4 times the diameter of Earth. It's thought the planet may have an atmosphere rich in hydrogen and helium. In these cold temperatures, it's likely it will appear as a bland, featureless sphere. Unless the planet is still producing some internal heat, in which case we may see structure in the atmosphere. Clouds of methane ice, ammonia, and even water
It all seems so exciting, and yet, despite the possibilities, so far Planet 9 is no more than a prediction in a computer model. They've been proven wrong before. So, very unscientific question, but the one that keeps coming up. How sure are you that this exists?
1,000,000,000,000%. So, you got an unscientific question, but a scientific answer. Right back at you.
But as a theory, you believe your models, right?
Actually, we try very hard not to believe our models. But look, if this thing is not out there, right? If the search comes up empty, then the outer solar system has some really, really substantial explaining to do.
And you ruled out the other explanations, right?
At least for me, it is difficult at this point to argue for a solar system that makes sense without Planet 9.
Mike, what about you?
So I'm slightly lower than a quadrillion%. The human brain is really good at seeing patterns, and when I can't sleep at night, it's because I'm worried that we saw a pattern and made up an explanation, and then as more observations come in, the pattern disappears. I don't think it's going to happen. I'm actually very convinced, but that doesn't mean that I sleep all through the night.
I sleep all through the night.
Yeah.
I am really eager to see it, to confirm it, to learn what it's like, to see that it has moons and rings, and I just want to know all these things.
And do you have any sense of what that will feel like?
You know, I bought a cigar about a year and a half ago, and it's still sitting in my desk. And I'm, every time that something dramatic happens, I always forget to smoke it. So maybe I won't forget that time.
You know, I'm gonna go buy a good bottle of champagne, and I'm gonna put it in my office. I'll put it in the fridge in our office, so keep it cold. And when it happens, we're just gonna drink it right then.
And between now and the cigars and the champagne, while we're waiting for the discovery, what are you two working on next?
We're looking for the planet, but we're also looking for more of these objects that are aligned, that are perpendicular, that aren't aligned or aren't perpendicular to prove ourselves wrong. You know, if anybody's going to prove us wrong, we would rather do it ourselves than to have somebody else do it. So we are trying very hard to prove ourselves wrong.
It's an exciting time.
It is. Let's hope it gets more exciting. Thanks a lot. Today's been incredibly exciting. The team's belief in Planet 9 is contagious, and I've become increasingly convinced that it really is out there somewhere in the outer wastes of the solar system. I'm sure I'm not the only one. There will be teams and telescopes from across the world racing to be the first to see it. And if it's found, when it's found, it will be the astronomical discovery of the century.
That's it for this programme. But don't forget to check out February's Star Guide on the website. Next month, we'll be looking at the top 5 photographs of the solar system ever taken. But in the meantime, get outside and get looking up.
The sun is tilted by 6 degrees with respect to the plane of the planets. The reason for the non-zero solar obliquity has been a mystery since it was first discovered by Sir Richard Carrington in the mid-1800s. It turns out that Planet 9 can actually tilt the sun.
The fact that the sun is tilted, even if it's only by 6 degrees, the fact that the sun is tilted, the sun is the most massive thing in our solar system by a huge margin, and it's oriented differently than everything else in the solar system. That is an incredibly strange phenomenon for which there really have not been that many explanations even attempted over the last 150 years. It's naturally explained by Planet 9 being exactly where we think Planet 9 is, which it's one of these mysteries that we think is now solved. It's been such a mystery that people haven't even really talked about it very much over the last 150 years because it's just been so difficult to think of what it is.
It has been known since the mid-1800s that the sun is tilted. Over the years, people have put forth various explanations for it. One possibility is that the sun was interacting with the protoplanetary disk via magnetic fields. It's also possible that the disk was just asymmetrical from the beginning. And it's also possible that the sun actually had a stellar companion a long time ago.
It was a moment of inspiration. Not all projects start out this way. Not all results really come. Some of them come, slowly dawns on you. We were sitting in Constantine's office one afternoon, and we were actually thinking about about a different problem entirely, which is how Planet 9 would interact with these very distant objects in the Kuiper belt that made us originally think that Planet 9 was there. And in just a moment, as we're thinking about it, we're doing this with our hands, trying to think of directions things are going, I think we both realized at about the same time, it's like, oh, it's going to make the sun look tilted too. And it was very clear from the way we did our fingers that it was going to make an effect. What we didn't know until we did the calculations was how much of an effect was it going to have and in what direction was it going to go. But we knew it had to do something.
Planet 9 has been scattered out into the distant solar system. So because it has an orbital period that's so long, it has an enormous amount of angular momentum. Okay? As much almost as the rest of the solar system combined. So even though as an object it is not as massive as Jupiter, it has a huge lever bar. Okay? And using that lever bar, it can effectively torque the rest of the disk of the solar system by 6 degrees over the age of the sun.
Next, always next on our list is find the planet. We think we have it narrowed down to a pretty small patch in the sky that we have to look at. Small patch in the sky still means we need many, many nights on the telescope. We're pretty convinced that by maybe the end of next winter, we will have been able to cover enough sky that we'll actually be able to find it. When we find it, we both show that this hypothesis has been correct. We learn about it, but we also see how much of the sun, how it should have tilted the sun too, and see if this is the only thing that's been tilted in the sun, or if other